So make sure you know them well. This is the what gas law?
No, it's the, that's the
Ideal
that's
gas.
ideal.
Ideal gas law. EV equals nRT. Pressure, volume, number of moles, gas constant, and temperature. What does this temperature always have to be in?
Celsius.
No, it's
Kelvin.
Kelvin.
Yeah, Kelvin.
Kelvin. And I guarantee you that the answer you would get if you use Celsius is one of the choices.
Whoa.
Just telling you now.
Okay, would be interesting. If they know what you're gonna get wrong and then they put it in the
Yes.
test.
What was the equation to get Kelvin?
It's C plus.
It's on your review sheet, or on your sheet.
That's not on the regular chem test, right?
No.
Oh.
Alright, this is the combined gas law. It's P1 V1 over T1 equals P2 V2 over T2. So pressure, volume, temperature. If one of these is held constant, then it just disappears. So if I say temperature is held constant, you can just cover that up and then it becomes P1 V1 equals P2 V2. If I say volume's held constant, you can just cover that up, then it's pressure divided by temperature equals pressure 2 divided by temperature 2. Questions on this? Alright. And another lovely triangle. This is an inverse triangle. So if temperature is held constant, so in this case it's not what you're looking for, but it's what's held constant, it's pressure times volume. If pressure is held constant, then it's volume divided by temperature. If volume is held constant, it's pressure divided by temperature. Alright. You'll all need to know about the gold foil experiment. So
That's
Rutherford,
like my favorite experiment.
well then I hope you get all those right.
School was like Casey.
This is the Rutherford gold foil experiment. What did he discover by shooting alpha particles through a very thin gold piece? Crisp.
That, okay, it was either that he shot alpha particles through and they didn't all get through because they hit something, or their trajectory was curved because something was charged.
Okay, so what did he discover based on that information? Yes,
That they have a nucleus.
that they have a nucleus. And that, what are they made of? Lots of, yeah, the nucleus takes up lots of space or very little? Little space. So those are the two things that came out of their experiment. It's mostly empty space, and it has a nucleus.
You can do that at home, dude.
And that is it for the review. Alright, any questions?
So that's all this is.
I mean,
Okay, so can you, so you know that list that goes like 1S, 2S, 2P, 3S, 3P, like, how does that correlate to finding the address of a, like, with electron?
it doesn't.
It doesn't?
The 1, 2, 3, 4, that's the principal quantum number, so that's the first number in the address. But that's about it. That's about it. They are two separate things.
So
that you don't
if it's in
even
like
know how to
D, you're
figure
gonna
out.
figure out like it was like the first
Okay,
little.
you guys need to sit down for a sec so I can finish getting questions. Yes.
So that's all from first
Or no,
semester that we're gonna be
Negative 1,
reviewing.
negative.
Okay, thought you were gonna bring up everything from first list.
Well, I went through your test and told you every topic,
Okay.
so.
Yeah.
Other questions? Yes.
I have, like, that's the only thing I'm following with, like, find the address. So could we do, like, another one that's not, like, the last electron, but, like, maybe the first electron is something like that?
Well, first electron will always be where hydrogen is.
Way to go.
So they go in order. So if I say I'm looking for nitrogen, yes, it's gonna go 1s2, right? Because we filled the hydrogen spot and the helium spot, and then 2s2 because we filled lithium and beryllium spot. Then we're gonna have 2p. How far across? Can you guys be quiet, please? How far across do we go? Well, I just said nitrogen.
I don't know, like, it's confusing to me.
Okay, boron, carbon, nitrogen. How many spaces did I go? 3. So I went 3 spaces in the p block.
Oh, okay.
So this is the electron configuration.
Yeah.
Okay. Now, if I want the address of the last electron in the S block for nitrogen. So that's going to be where beryllium is, because that's the last S. So the highest S orbital I have is the 2s. And the last electron is going to be the second one. So the address, it's in row 2. Yes? Okay. What block is it in?
Yes.
S block. Now, because it's in the S block, we don't have any suborbitals,
Okay.
so it's still going to be another 0. And we fill them positive electrons first, negative second. So if I do positive where lithium is, what am I going to put there? In beryllium.
Negative?
Yep. Negative 1/2. So this would be the location of the last S electron of nitrogen.
Okay. So it's like, it's based upon other elements than, like, in the periodic table.
Well, it's just based on spaces.
Okay.
So if you ask for the last valence electron of something, that's where it is on the periodic table. Anything else, you'd have to look. So if I said, what's the address of the last valence electron in the nitrogen 3- ion, then we're going to add 3 more electrons and we get to neon, right? So now you're giving me the address of where neon is.
Oh, okay.
Does that make sense?
Yeah. So, sorry, this is the last question. I get the first number, the second number, and the fourth number. But what? So we deal with one that didn't have a suborbital. So how would one look that does have a suborbital?
So p orbital has holds 6 electrons.
Okay.
Each suborbital holds 2. So remember, it's going to go -1, 0, 1, -1, 0, 1. Okay? For the p block. So if I was looking for oxygens, last valence electron, its third number, well, its second number would be 1. Its third number is going to be, so if we go -1 where boron is, 0, 1 where nitrogen is, then we start over again, so it would be -1. And because it's the second electron we'll be putting in that -1, it's going to be a -1.
Oh, okay. Yeah, that makes sense.
Okay? Yes, Chris.
The S is 0, but why didn't they just put it as 1?
I didn't create the process, Chris. I don't know why.
It'd be easier if it was 1, if it was like, if it was S.
You know, scientists don't do things that are easy, so it's just the way scientists work. The only thing they do that's easy is naming things. They're
And
incredibly
giving
obvious.
zeros to things that aren't 0.
It is 0. The shape of the orbital is a 0. It doesn't have any suborbitals.